Get started. So today we're going to talk about changing dimensions. So the first thing we got to think about is what is a dimension. So we're talking about the different measures. Ooh, that is a bad choice for colors. The dimensions of a figure. So it's the measurements. It's the height. It's the base. If we're talking about a triangle, it's going to be that same height and base. If we're talking about a parallelogram, that same height and base. And if we're talking about a trapezoid, we're talking about the idea of base 1, base 2, and the height. Now, we could be talking about anything that measures from side lengths to all those things. So today we're going to talk about this idea. The first thing we have to understand is remember what the word similar means. So similar in math has a specific meaning. Same shape, but different sizes. Okay, where you have congruent, which is same shape, same size, exactly the same. So these two shapes are the same. Same shape, but different sizes. Same figure, both are a decagon, and they're a 5-point star decagon. So one of the things we know about them is that if we could figure out perimeter, that we know that there are 10 sides, so each one would be 4, 4, 4. All these would all be 4 inches. Or units or whatever. So since there's 10 sides times 4, the perimeter of this is 40 units. Okay? If we take a look at the same idea, now we have a similar figure, same shape, but a different size. This is 12, 12. So every side now is 12 units. That makes this one's perimeter 120 units. Okay? So how are they different? How could I figure that out without having to figure out all the addition and all the math? There's a way to see they're related, how they're connected. Well, if we go back to the side length, how many times the smaller side length is the larger side length? Well, it's 3 times larger. Look at also the perimeter. The perimeter is also 3 times larger. So the perimeters in a similar triangle are directly related. They're exactly the same, that 3 times as many. Okay? So if one side is 3 times bigger than the other side and they're the same shape, then the entire thing, the relationship is going to be 3 times bigger for the perimeter. And that's exactly what this says. If the dimensions of a polygon are multiplied by a number x, then the perimeter of the polygon is multiplied by that same side, that same amount. So if I take the perimeter of figure A, so in our case before it was 40, it was 3 times bigger. That gives me the perimeter of figure B, which is exactly what we figured out on our last paper. And that's exactly what's true on this paper too. Okay? So let's use that information a little bit. So we've got 2. We have 2, the side lengths of a parallelogram are tripled. What effect will that have on the perimeter? Well, first thing we know is that it's tripled. So we said the math says from figure A to figure B, that's an A, there's an A. Figure A to figure B, it's going to be directly related, so it's going to be 3 times larger. Okay? Because the parallelogram says one side is tripled, therefore the perimeter will be tripled. And let's see if that holds true. So if I have a perimeter of this, so 4, 4, 3, 3, that's 8 plus 6 is 14. Let's check this one. 12 and 12 is 24. 9 and 9 is 18. 18 and 24 is 42. Well, 14 times 3 equals 42. So that holds true for our information. What about for a pentagon? Now, this one I didn't specifically leave the idea because I want to put a new idea in. What if it's half the size? What if figure A is larger than figure B? What would that effect would that have on the perimeter? Pause the video and write down what you think. All right. So from figure A to figure B, it's half smaller, so it's going to be half the perimeter, half the length of the perimeter. And we can prove that saying this one, if we say, okay, these are all together it's 5 times 8, that's 40. And if I cut everything in half, I'd have 4 times 5, which is 20. Well, 40 times 1/2 is 20. Put my units on there just so I can satisfy myself. All right, now the same thing, now there's something different about area. Area is a little different. So again, these two figures are similar, okay? What can you tell me about the area of the two figures? Now this is where it gets a little bit more challenging. Look, we have that same change. We can tell the difference in these two ideas. Okay, well, so that's the height right there. Okay. Height is 3 on this one. The height on this one is 12. Okay. So how much bigger is this one than this one? It's 4 times bigger. You're right. So it's 4 times greater. Now the difference about this is a little different because we have 2 different information points. We're not just adding up all the dimensions for perimeter. We're actually multiplying both dimensions. There's 2 dimensions we have to figure out, 1/2 of base and height. So if I'm thinking about how I do this, 1/2 of the base, so it would be base times 4, and height times 4. So but without even knowing what the height is, I've had to multiply both the base and the height by 4. So what do? Well, if I brought my 2 numbers together, that means this is going to be 16 times larger. And that's how that works. Because I have to multiply both dimensions, and they're both being multiplied, then I have to multiply both the numbers, so it's actually 16 times larger. That's the difference in here. So let's take a look at that, exactly how it says. Now, another way to think about this, and I like this because I think of the units. Perimeters is just a unit. Area is unit squared. So here, the multitude would just be times 2. Get my pen out. There you go. Would be times 2. But here, because I'm multiplying both this one by 2 and the height by 2, this would be 2 squared. I use my units to help me remember what the magnitude is. 2 to the first power is 2, 2 to the second power. That makes my magnitude 4. And that's what's going to happen with the area of the figures. It's always going to be the magnitude squared, the amount of change squared. Okay? All right, so if we take a look at our triangle here, the side lengths of this triangle are multiplied by 5. What effect is that going to have on the area? Well, without finding out the area, we're going to know that, okay, since both of the dimensions are multiplied by 5, 5 times 5 is 25 times greater. So that's going to make the area 25 times greater on figure B. So figure B is 25 times greater. Okay, so let's just check that to prove it. So we have 1/2 of 1 times 2. Well, half of 2 is 1, so 1 times 1 is 1. So the area of figure A is 1 centimeter squared. Let's see, figure B is 1/2 times 5 times 10. So figure B's area, so the area of figure B is going to be 25 centimeters squared. And again, it exactly fits with what we just came up with. All right, take a moment and do the same thing on your practice problem. Find out what effect it will have on the area. Don't worry about calculating the area. Just find what the effect is. You're right. So if it's tripled, there's the keyword, multiplied by 3, it's going to be 9 times greater. And if you test this math, the first one, if you do this before you change it, it's 24 meters squared. If I multiply 3 times 9, or sorry, not times 9, times 3, I apologize. 3 times 3, you get 9. And 8 times 3, you get 24. Well, 9 times 24 is 216. And if I drive this and divide 216 by 9, I get, 216 by 24, I get 9 times greater. So it definitely is holding true as we go. All right, now you don't know how to find the area of either one of these shapes. Can't do it. You don't know the formula for an octagon, and you don't have the bases and the heights for the trapezoid down below. So let me show you how to do it on number 3, and then I'm going to have you practice on your last one. So a stop sign is in the shape of a regular octagon. So all that really means is it's the same shape. Figure A has an area of 309 inches squared. Okay, what is the area of figure B? Well, I have everything I need because I can tell what's the magnitude of change here. So if I go, okay, how many times? So to get from 8 to 12, I've got to multiply by 1.5 or 3/2, or you could use the decimal 1.5. Either one works. And since I know I have to square that, I'm going to use my calculator, or I'm going to use my brain, and then really when I square here, all I do is square both terms. So this becomes 9/4. This becomes 2.25, which they both happen to be the exact same. So this is 2.25 times larger than that one. So to figure out the area of figure B, I'm going to take figure A, 309 inches squared, and I'm going to multiply it by 2.25. And I'm getting out my calculator as we speak because I don't really want to do that one in my head. So 309 times 2.25. My figure B area, figure B, has an area of 695 25 hundredths inches squared. Okay? All right, pause the video and see if you can figure out the area of our second trapezoid. All right, so now we can take a look at this one. We have an area of this trapezoid being 6. We know that this is 5 times larger. So the area is going to be affected by 5 squared. So 6 times 25 says the area of my new figure is 150 millimeters squared. Okay? All right, today you guys are going to try the ticket out the door. Determine the measure of a rectangle is 3 by 4 feet. If the dimensions are tripled, what effect does that have on both the perimeter and the area after they're tripled? Do not find me the perimeter or the area. Just tell me the effect. Pause the video and you can check your work at the end. So the perimeter's effect would be tripled, so times 3, and the area's effect would be multiplied 9 times larger. All right. If you have questions, please reach out and talk to me. I'd be happy to help you.